Okay. All right, another example. And Riley, I'll just go back and show you this. So basically in this problem, the blue is the initial, like the parent function that's not been shifted. Then purple was the shift left, and then red was the shift up, which is the final graph of what that would have looked like. So, if you go back, that way you know what that was talking about. Yeah. Normally, I was like, I don't care if when you shift, if you do it all as one thing. I like to do at least the parent function first. And then if I'm going to shift left or right, up and down, you can do that all at once, or you can do it separately. So I just did it in steps, but it really doesn't matter. All right, this one, m of x, I don't know why. Anyways, is equal to sine of 2 pi x minus pi over 2 minus 1. So the formula for graphing these is, oh, hold on. My formula might be different than what they have in their book. I might need to fix that. Or the formula that you'll have in your notes might need to be fixed. Where is it? Come on. Okay, well, in here, they say that they have modified the formula, the general formula, to say, like, the sine, or a sine of b times x minus c plus d. And so they say that when it's in parentheses like this, the number in front of x has to be 1. So we need to take out a 2 pi from this parentheses, basically, is what they say we need to do. Which I do remember having to do that when I was in high school, but the way our book writes the formula versus the way this writes the formula. So, and I think they write it this way from the standpoint of they want you to see that there needs to be a 1 there. So, step 1, just the way we were doing it yesterday, we've got an amplitude of what in this problem? 1. There's nothing in front of sine. Step 2. So this is where we do the period. Right, that was step 2. Yeah. But we need to take out this 2 pi first. So I'm going to do it up here. And then I'll come down there and do it. So we're going to have the sine of 2 pi times x minus. Now what happens if I take out a 2 pi from this?
Well, that's a pi over 2, so that'd be...
So I know the pi is going to go away. And I'm taking out a 2. So I'm like dividing by 2. So what's going to happen?
So like 1/4?
Sort of. I think you're on the right track. But yes, it'll be 1/4. Because if I multiply this back through, that's going to give me 2 pi over 4, which is going to reduce to pi over 2, which is what I started with. Then minus 1. And so now this is what we're going to use when we're doing our shifts and everything, is this modified 1. So I'm just going to make a note so if Virginia goes back and looks. Modified because number front of x must be 1. Now, 2 pi is still going to be b, just like we see here, but... Alright, so now, to find the period, it's 2 pi over 2 pi, so it's just going to be 1.
That's nice.
So yeah, so that'll be nice. So then our scaling, so step 3. So basically, what are we taking and dividing by? So we take the period and we divide it by 4, and that's going to give us the 4 points that we use to get one full cycle. So that's going to be 1 over 4. So that's our scale. Step 4, we're looking at our shift. This one is the shift left and right. So which way is this one going and how much?
Right 1/4.
Right 1/4. And then step 5, up or down? Yep. Down 1. And is it reflected? No. So I'm probably just not even going to write that it's not reflected. Yesterday when we were doing it, I was writing like every time, I was doing every single step, but like if there wasn't a shift left or right, I probably just wouldn't write that. I would probably just, I just think this is kind of a good way to keep it organized and make sure you go through everything. So set up my graph here. And I told them yesterday, Riley, that you can do both sides of the graph if you want. The prep book really only does the right side. Our book tends to tell you to go from -2 pi to 2 pi, which is going to give you typically 2 full cycles, because 1 full cycle gets you to 2 pi for the parent function. So you'd get a full cycle on the left and a full cycle on the right. But unless they specify, it doesn't matter what you do. A lot of the ones that I see in the problems in the book tend to want to ask you, they either ask you these kind of questions that came from the steps up here, or they will give you pictures of graphs and say which one matches.
Yeah.
Or like which one is what the result should look like kind of thing. Yes.
So how far in each direction are we going in the example here?
So the period is 1, so I'm going to go out to 1.
On both sides?
Yeah, I'm probably going to count by 2s just so it's split up a little bit, but we can do both sides, or you can just do one. It doesn't matter. I might just do one side, because if you can do one side, you can do the other.
Okay.
So this is going to be 1. So then increments of a 4th. And so the nice thing about this is when it's funny, I was telling them yesterday, I've never seen the thing about finding the scale. I was always just kind of told, just like find this one, cut it in half, find that one, cut it in half, and then figure out what halfway between those were. And I was like, for some reason, some of those just really threw me for a loop.
Yeah.
Like trying to figure that out. So it's kind of cool to see it this way, because then you can just count, like even when it's in increments of pi, or like, pi over 3 or something, it's like 1 pi over 3, 2 pi over 3, 3 pi over 3. You know what I mean?
Yeah.
So it just makes it a little nicer, I guess. All right, so I'm going to start with the parent function if this was not shifted at all. Amplitude of 1. So we'll go here and here. All right, and this is a sine function, so that means I start where?
At the origin.
The origin. So I start here. Then I counted by 2, so it's going to make it look weird. But in the increments of where I'm at, I would go up to here, down here, and back up. And so this would, and in this direction over here, this would continue going down. So that's the parent function not shifted. Do y'all want me to do the next thing in 2 separate steps, or do you want me to do it all in one, the shifts?
Well, yesterday I had the unshifted one as just like these little dashes, but then I did the first shift with like a little squiggly line, and then I realized that's not the best way to depict it, but just pretend it's straight at this point.
Do you want me to do both shifts at the same time, or do you want me to do them separate?
Separate.
Okay. All right, so I'm going to do the step 4 shift, so that's going to be the right pi over 4. So I'm going to take every point, I'm going to do this one in red, and I'm going to shift it to the right 1/4. So I'm going to come over. Basically, every point is just shifting to the next marking on here.
Yeah.
So this point is coming here. This point is coming here. This one is here. This one is here. And then this one would be over here. So that would be at, 1 1/4. So then connect it. Try to find a color that'll be distinctly different.
Kind of looking like one of those cosines.
I was gonna say purple, and then I'm like, that's just a combination of
Yeah.
the two. That's probably not it. I'm gonna try green. Hopefully, it'll be able to be seen. And so then next is down 1. So I'm gonna take every red point and shift it down 1. So I'm gonna end up down here as -2 then. Gosh. Just realized my graph is off.
Oh no.
Because I did, this point was already down here at -2. This should have been 1. I'm just gonna, it's just gonna look weird. I'm gonna just call that -1 for the sake of what's happening. But anyways,
You can pretend.
just pretend that it's right so I don't have to redo the whole thing.
Yeah.
Oh gosh, hold on. This point's going down. Anyways, it's fine. It's just the scaling is a little off. It's fine. I'm just gonna leave it. So I'd have to go back and fix 3 graphs now.
It's kind of looking like a reverse, like a reflected cosine graph.
I'm gonna reconnect my green dots. They don't look right.
Yeah, I brought mine all the way onto the left side. I went from -1 to +1.
It's good enough. Anyways, it should look symmetric, obviously, because I should have grabbed it where it was actually like that. But anyways, it's fine. We'll get the next one. All right. Any questions about those at this point? Okay. I'm going to jump to the actual book now and do some of these. All right, the first one's just basically say like what the amplitude is of the function. So I'm just gonna probably do like one of those. So for y equals -7/4 sine of x. So what is the amplitude?
7/4.
7/4. And since this one has it, what else is happening to this graph?
It's reflected.
It's reflected. So if we were to graph this, these ones don't tell us to graph it. Basically, where the point for sine would start at 0 and go up, we would start at 0 and go down. It's just flipping it over the y or the x-axis. Find the period of the function and use the language of transformations to describe how the graph of the function is related. Okay. So, like 8 y equals the cosine of x/5. So what would the period be for this? If we need to, think about this as the cosine of 1/5
Would it
x.
be like 10 pi?
Yeah, so we would do 2 pi over 1/5, which keep change flip would be 5 times 2 pi, also known as 10 pi. And I'm not going to write it, but what's the amplitude of these? This one. It doesn't ask us for it, but it's 1.
Is the amplitude just the number in front of sine?
Yeah.
Cosine.
Yeah. And if it's amplitude's always the absolute value of. So if it's negative, the negative, basically you can disregard the negative in terms of amplitude. The negative is just going to tell you it's reflected.
Alright.
Isn't frequency just like the reciprocal of period?
Yeah. Basically. It's b over 2 pi. Let's see, 12. So we can just talk about everything that's happening with this one.
Loudness or something?
No.
Just
These,
the loud-
that's why I said I wanted to do the ones out of the prep book instead, because these ones are honestly like so chill it's not even funny. Like the hardest problem doesn't even have shifts in it that I see. Until you get to the very end. Problem 61, you finally shift.
Oh.
Basically. So I'm just like,
At least they're steady. Yes. Not shifting all around.
Alright, so this one, 1/4 cosine of 2x over 3. So what do we know about this one?
Okay, so the amplitude is 1/4.
1/4. Period.
So that's 2 pi over 2/3.
Which is going to be
3 pi.
3 pi. All right, the next ones. The next ones want amplitude, period, and frequency. They talk about graphing these, but I'm probably just going to hold you on the graphs of these because these ones aren't really anything too exciting happening. The ones that are shifting, like the first step of graphing a shifted one is graphing the basic, so I would rather us just graph the harder ones. So we'll probably wrap up with this today, and then we'll finish up graphing tomorrow of sine and cosine. So 14, amplitude, period, and frequency of y equals 2 cosine of x over 3. So amplitude is
Really? Go
Oh,
for it.
2.
2. Period is
6 pi.
6 pi, so 2 pi over 1/3, which turns into 6 pi. Then frequency would be 1/3 over 2 pi, which just ends up being 1 over 6 pi. Which, yes, you could just invert period. I know that's what you're about to ask me.
I wasn't gonna ask any.
Oh. You looked like you were about to ask me a question, so I was just like, I'm just going to go ahead and answer it before you have time to ask.
I guess my face was saying.
Whatever period is, frequency is the inverse of it.
Yeah.
It's like literally all it is. And they, again, if there was a negative in there, which we don't really have to deal with the negatives, we would flip it. Let's see, one more of these, and then we'll probably just, well, I might go ahead and write the problem for tomorrow that we'll start with, but 16, y equals negative 4 sine of 2/3 x. Yeah. So amplitude is, period is
3 pi.
2 pi over 2/3, which is 3 pi. So frequency would be
1 over 3 pi.
yeah. I'm going to write it out just so Virginia looks at it. She can see it. But 1 over 3 pi. What else do I know about this?
It's reflected.
It's reflected. So, not that they asked, but it's good to go ahead and point it out. All right, so at that point, what I'm probably going to do, if you look in your book, you're going to see some problems where they give you a function and they want you to explain what's happening based on the picture that they give you, but those are kind of weird. And then there's a whole bunch of identify what the max and min, which basically amplitude is, of the function, and like describe the transformations, but there's no transformation other than the fact that it's being like stretched. And so then we'll jump all the way to the end, 61 through 68, and look at a couple of those graphs. So we'll probably start with 62, so if you want to just go ahead and write it so it's there for tomorrow. Y equals negative 3.5 sine of 2x minus pi over 2 minus 1.
That looks kind of familiar.
So immediately what do we see is going to be a problem?
The 2x.
The 2x, so we're going to have to take that out. But I'll wait and do that tomorrow. Y'all have a leg up on Virginia tomorrow if she's back.